Okay, so the topic for tonight is color management, and what I'm going to show you is something that I cover in a class that I teach at the University of Akron. Only there, I cover it over several class periods. So what we're going to do tonight is kind of condense things and give you a lot of information. Certainly ask questions if you need to, and I'll do my best to, do a good job. And like I say, it's difficult to take a complicated subject like this and condense it down into an hour. But anyway, I'm going to give it a shot, and it worked out pretty well last time. So we're going to start off with a definition, because I find there's a lot of people, and those of us, and I'm going to assume that everybody here in this room works somehow or in some way in digital publishing, maybe photography or illustration, graphic design, and so forth. But what we all have in common is we work with digital imaging devices. And a lot of people don't really understand, well, what does color management mean? In fact, I had an email from somebody before this presentation asking me a question about colors and color swatches in Illustrator. And I can understand that she would send me that question, because you might think I would know the answer, but I don't. I don't even use Illustrator. Because color management is not about how to use colors in Illustrator or how to use colors in Photoshop. It's much more broad than that. Color management is actually a subject that came out of need, because years ago when digital imaging and desktop publishing were evolving, corporations and scientists and technical people that work at places like Microsoft and Apple and so forth realized, we got a problem, because we've got all these computers and computer users and images, and ultimately images are made up of numbers, if you think about it, right? And we need some standards for how images should appear to the end user on a monitor or off of an inkjet printer, things like that. So they came up with a system, and that system's name is color management. So color management means that you're talking about this system that's been created, look for my pointer, here it is, so that you, the user, can control and predict how colors will appear through a color management workflow. That could be digital camera, into your system, into perhaps Photoshop or Lightroom or Illustrator, whatever, and then out to maybe an inkjet printer, or maybe to a printing press. Maybe you're sending it to Copy King, perhaps downtown Cleveland, and having your images output there. Okay. In addition, color management tells a program, it instructs a program like Photoshop or InDesign, and that's just two out of many. There's many programs now that are color management aware. I just happen to pick those two. And so the color management part of your computer, let's say the software, and it's built right in. I mean, when you buy a new computer these days, there's color management software that's under the hood. And it is telling programs like Photoshop or InDesign, well, how should the images appear? What should the color look like? We're going to get more into the details of that. In addition to that, it also attempts, and attempts is a good word here because it's not always a perfect process, but it attempts to maintain the appearance of colors as the image moves, or the document, you could also substitute the word document, moves from device to device. Say, for instance, some of you perhaps maybe work in an organization where there's several of you who might work on the same image, same document. So the document goes from my computer to your computer to your computer and back and forth. So it's moving between systems, and even if you're using the exact same computer and the same model of monitor and so forth, when you really analyze it and get right down to it, that doesn't mean the image is going to look exactly the same from device to device, because that's just the nature, that's life. That's just the way life is. And let's say technically, so far, nobody in manufacturing that I'm aware of has gotten to a point where they can produce 5 monitors and all of them will display color exactly the same. And if they could, well then it would simplify this process, but that hasn't happened yet. So anyway, so that's part of what color management does. Okay, so we're going to start with some definitions in order to understand how color management works. And so we'll start with this definition right here, color gamut. Anybody know what color gamut is? Some of you probably have read about it. Go ahead. What is it?
It's the range of colors that a particular device is able to see in print. So I know it's a different pattern for CMYK and RGB.
Right? You get an A. One of the things she said that's very important, and I'll repeat it, and actually I'll put it up on the screen to be even better. She used the word range of colors. A lot of people mistakenly think that a color gamut is the number or the quantity of colors, but no, not really, it's the range. So, and I'm going to try not to make things too technical, by the way. So let's just leave it at that, but the point being...
I want to make sure they can see.
Okay. I'm a little distracted, folks. I got a spike in my peripheral vision, a lot. So anyway, color gamut is a description of the range of colors that might be in an image or that a device is capable of displaying or creating or printing, etc. Okay. And because I find analogies helpful, an analogy I like to use is, well, if you think back to first or second grade, when you might start off the year of school with a new box of crayons, wasn't that exciting? And if your mom really gave in to your pressure, you might walk out of the store with a big box which has lots and lots and lots of colors. That's a big gamut versus the smaller boxes. So again, it's the range of colors. So what's important to understand really here about color gamut is that different digital imaging devices, and here's just a list of a few, have unique and different color gamuts. So now, for instance, you might, and I'm sure many of you have maybe seen ads for monitors, and you might think to yourself, wow, I wonder if that new ISO monitor is worth, whatever, $1,800 and so forth. Well, one of the things you get when you pay more for something like a monitor is a wider color gamut. Because a really, really inexpensive monitor, one of the things they can cut back on is the range of colors that it can display. So that's going to affect very much how you interpret what your image looks like. So that's why it's usually good to get that large gamut monitor. So again, it's important to understand that with these color ranges, the color gamut, basically the difference is some are small and some are large. Okay. All right, how about a color space? What's a color space? Anybody?
CMYK, RGB.
Those are color models.
Oh, there. Okay.
And a lot of people think CMYK is a color space. It's not.
Okay.
It's a color model. Within CMYK and RGB, we have color spaces. So, okay, all right, I'll tell you. You see, a color space is basically just a description of a color gamut. But it's a description in scientific, technical, numerical terms. It's a very, very accurate description, something that could be measured and repeated with instrumentation. It's the kind of thing that color scientists really get into. So when you can define a color gamut, numerically and so forth, what you're really doing is you're defining a portion of visible color. So you're saying, okay, I want to take a particular shade and hue and saturation of red, and I want to attach a number to it. And every time I measure that particular color, I'll get exactly the same number. That's what then makes a color space. So here's some examples. Here's color spaces. I have a hunch most of you have seen these terms at some point in time in your work. And so I want to point out that we start off here with this, which is very, very common, sRGB. Do you know what the S stands for in sRGB? Anybody? It stands for standard. Because remember I talked about how years ago when desktop publishing was evolving, there were meetings of people, technical people from various companies, and they decided, you know what we need? we need a color space in RGB that we can all agree on, and we'll call it standard. How about sRGB? Yep, sounds good. Okay, voted in. So that's what sRGB is. It is a numerically defined, measurable color gamut that everybody could agree upon. And you will find that most devices, by default, use that color space because that's the standard RGB color space. So for instance, an iPhone, for example, last time I had a student check, it produced an sRGB image by default, and that I was completely expecting that. Anyway, so what usually happens though when you have a standard of something, when something becomes vanilla, becomes plain across the board for everything, what usually happens? It's usually not the best. Sure, everybody can agree on it, but it isn't necessarily the best. Or let's say in this case, it might not have the biggest color gamut. In fact, it does not. So although it's universal, it's also the least exciting, and it has the smallest color gamut. In other words, the amount of colors, the range of colors is very small. It's the smallest of these three. So if we were to look at other examples here, Adobe RGB is obviously something that Adobe created, and it has a larger color gamut. So I'm going to get a little bit further into that in some upcoming slides. This right here is what? Many of you should know what that is. It's a CMYK color space. So to answer your comment, so CMYK itself is not a color space. US Web Coded Swap version 2, that's a color space. And it has a defined color gamut. And you talk to any printer and they know exactly how the color should look. Correct me if I'm wrong, Mr. Henry Lee.
We should, or I should be just leaving this room right now.
Okay, so here's just a little bit of a fun trick question that I asked. Those of you that already know the answer, hold back. So anybody want to tell me that? What's the largest color gamut, largest gamut of a color space that we might work with? The largest. It's something we all are aware of. It's human vision. I'm a photographer by trade. So as far as I'm concerned, colors I can't see, they don't matter to me very much. But the colors I can see, absolutely. So my goal is to capture and display and work with as much color as I can. So the framework, let's say the background, the reference for this whole topic is human vision. If we were to take all the colors that a typical human being can see, we were to plot them out on, let's say, in two dimensions using colors and so forth, you would come up with a shape that looks like this horseshoe. And right here in the middle, this would be pure white. And these are all the various shades and hues and saturations of colors that the average typical human being can see. And color scientists, again, they studied this, they arrived at this long ago, and this is the accepted reference point for color management and for color spaces. Last time, and when we had our little impromptu meeting, one of the participants asked a really good question, and nobody had ever asked that before, and it's so good I'm going to repeat it. And he said, how come there's so much more green than there is red or blue? How come this part sort of sticks out and is more expanded? Anybody know the reason? It's because our eyes are more sensitive to greens than the other colors. So we can see a greater range of greens and greater differentiation between greens than we can the other colors, and that's why this plot looks like this. Okay, so that's a good reference to kind of keep in mind as we go through tonight. Okay, so within different color spaces, you have very different color gamuts. And this is important because what you find, if you think about working in Photoshop, and I have a hunch most of you probably have some exposure to Photoshop, and you know what the eyedropper is, the tool that allows you to roll with your mouse over an image and measure a particular area of an image. And you usually can measure things like its brightness, and you can measure numerically, well, what color makes up that very point? You can even have it tell you pixel by pixel or 3 pixel average.